Imagine a world where, when you wanted to start your coffee pot in the morning, all you had to do was think about it. Or instead of saying, okay, Google, or hey, Siri, it just happened. That is brain-computer interface, or BCI. It's the collaboration between the human mind and a device triggered by some response and only brainwaves. It's something humans have been dreaming about for decades. And now we're closer than ever to making those dreams realities. This semester, we wanted to contribute to that in a very unique way. I think we did it. Our project is called The Guilty Magician.
The Guilty Magician test is our version of a magic trick, except we use brainwaves in order to determine which your card is. What we do is we have our subject pick from a deck of 52 cards, and they pick a single one and they memorize it. And then we have them focus on that card as best as possible. Then, using our STEM software, we provide them with a series of stimuli, and it's just the deck of cards. It continues to flash them onto the screen, and then our subject just continues to look at them and focus, making sure that he or she is always thinking of their card. By them focusing on the card, our technology processes the signals in order to detect the P300s, and then we're able to repeat back to the subject what their card truly was.
The premise of the Guilty Magician experiment is to basically figure out a way to read someone's mind. That's sort of the heart of what we're trying to do here.
Well, the Guilty Magician was introduced as a fun and interactive way to introduce the concept of brain-computer interfacing and the potential of the use of the P300 response for other applications.
This experiment builds the fundamentals behind EEG and BCI as a whole. It's a pretty basic experiment that almost anyone can do on their own time, and then from it you can build off of it to make it something bigger than what it is, or use it in real-world applications.
Our whole experiment is based on this idea called the oddball paradigm. And at a very high level, what that is a subject is shown a series of stimuli. It could be audio or visual, but in either case, it's made up of standard stimuli, which don't really mean much to the subject. And then mixed in every so often, there's a target stimuli. And that target stimuli does have some special meaning to the subject. And that response that we see in the EEG signals from that target stimuli is the P300. So, for example, a dog owner knows what his or her dog looks like. So that person will be shown a bunch of pictures of dogs they don't know, the standard stimuli. And in the mix, there are a few pictures of that person's dog, the target stimulus. So the idea is, when that person's dog is shown, the EEG signals would show a different response than when the owner is looking at the other pictures. That is the oddball paradigm.
So STIM is the program we use to generate different stimuli to be presented to the user. A stimulus is basically some kind of physical phenomenon that is sensed by the human's sensory organs and is transmitted to the brain. When the brain receives these stimuli, it generates different responses depending on what the actual stimulus is. So the STIM program allows us to generate different types of stimuli from audio to visual. For this specific experiment, we actually use visual stimuli, which is the cards that you see on the screen behind me.
Our experiment is really unique in that typically with an oddball paradigm test, the target stimulus is known. But we don't have that luxury with the Guilty Magician, which presents a little bit of a challenge. So to solve this, our software has to be written in such a way that it will iterate through all of the possible target stimuli until it finds the response it's looking for and shows the user its card.
So given the fact that we're working in a university environment, there's several natural constraints that we have to look out for that come from working in such an environment. The first of which is the fact that we're only provided a certain amount of hardware. Should any of the hardware fail, or should we have any issues with it, that will certainly pose an obstacle for us to overcome. Additionally, there's only a limited amount of demographics available in the university, so most of the people that we're going to find are going to be young college students.
Since we're using a human subject, we can't have a test that runs for 30 minutes long. It's unreasonable, and it's going to make them uncomfortable after some time and make them lose their focus. We have to be able to design tests that are limited to maybe less than 5 minutes long to keep them at the most comfortable level, but we also at the same time need to be able to gain as much stimuli and as much data as possible while using as least amount of time.
it's important to ensure that there's a small amount or little electrical risk to our subject. So with our nuance amplifier and our EEG cap, we run, and the other electrical equipment we use, we run it all through an isolation transformer, which is rated medical grade. This ensures that the power supply is stable and that the subject is at little to no risk of electrical injury.
As students in the university, we were already provided the software and the hardware for doing this project, so we didn't have to put any of our own funds out. So we have those resources readily available to us. In addition to that, there's multiple resources online that can be accessed because BCI and EEG isn't something that's brand new. It's technology that's been out there for some time now, and we can look at past projects done in order to further our projects as a whole.
So some of the resources available to us during the course of this clinic were the manuals provided to us for the software, many books related to digital signal processing, brain-computer interfaces, things of that manner. And additionally, one of the resources that we found to be most helpful was people who have run the clinic in the past, because they were able to pass their experience on to us and allowed us to get much further than we would have without them.
There are quite a few standards to which experimenters should adhere when performing the Guilty Magician test, among the most important of which are the guidelines set out by the American Clinical Physiology Society for clinical EEG use and EEG measurements. Things like nomenclature, electrode position, signal recording, and the like.
So I think the people who would most benefit from such an experiment would be people working in the law enforcement or criminal justice field. The Guilty Magician is a derivative of the Guilty Knowledge Test, which can be used as a form of lie detection. Instead of detecting false information, though, it detects hidden information. So this test could be applied in such a scenario. Additionally, anyone working in medical fields, possibly in research areas, could use brain-computer interfaces to determine what kind of responses are elicited from different stimuli. There's a lot of different experiments or studies that could be done with such technology.
It can also be applied to other fields such as entertainment. VR is all the rage nowadays, so the ability just to read the mind in terms of virtual reality would open up many more opportunities.
Since this experiment can be used in so many different ways, virtually anyone can benefit from using this technology as long as they know how to use it properly.
I'm very passionate about education, and not just institutional education, but education in general. So my favorite part about this experiment is that it provides such an easy and interactive way for people to learn about brain-computer interface and the implications that it might have on their lives.
I think my favorite part of the clinic is being able to tell other people that we're developing a mind reading application. I know it sounds silly, but it gives people, especially people who aren't involved with engineering, an idea of how cool it can be. Just the things we do are so out there sometimes. I think it can really help to get people excited about the field, even if they're not involved as much.
As a mechanical engineer, I haven't done much in the field of data processing and filtering, and I feel that my involvement in this clinic has certainly expanded my knowledge on these fields.
I'm most excited about the possibilities in this project. I came in here thinking that it was going to be more medical based, but it turns out that wasn't the case. But just by doing something that isn't what I wanted, I can see that the possibilities in it, though, are still there. It can still be used for exactly what I want it to be used as, even if that wasn't exactly what we were testing throughout.
At the very core of our experiment lives this idea of brain-computer interface. Literally talking to and controlling a computer with your mind. It's amazing to think of what that means for the world. We've already come leaps and bounds from what we even thought was possible. We live at the edge of impossibility. This project is just another step toward the future of the mind and tomorrow's world.